Okay, this is a update for the Kaiju Engine. I don't have a particular issue for this task, but I'm doing some cleanup and also I'm porting a program that I wrote in C that I also published to Android and all that other stuff. I wrote it in my C engine and I'm trying to rewrite it in the Go engine. So there are some things that I needed along the way, and that's what this is going to be. So the first thing is I didn't get a video on this, but it's pretty simple and straightforward. You'll notice that the languages here on the GitHub repository is now Go as the most part of the language. It used to be C, was like 99%, and that's because of the GLAD, the GL headers and C files and the Wrangler files for OpenGL, and that was taken up, and that was there's a lot of code in there, and so the code base when people would come here would say that C was the primary language, which is confusing for a Go engine. So I thought that I would go ahead and kind of resolve that just visually for people. So the solution to that is pretty straightforward. Just inside of the GL, you add a dist folder. GitHub uses, I forgot what it was, some kind of markdown or something, not markdown, some kind of configuration language, and there's a bunch of folder names that when it detects it, it just ignores everything in there. So I created a distributable folder under the GL and put all the C and header files in there for GLAD, and Windows didn't want to compile the code because uh, I guess it was in a separate folder, so I added this glad.go file, which does nothing but include the glad header. And then inside of the GLAS non.js, I just added a what was this called in Go? I don't know, an unused package to that folder, and that made it happy and it started building. So that's the main thing I did there. And the rest of the C file stuff, the C code here, is for the window code for Win32 and X11. That's the windowing code. So this is probably going to diminish as we go because we're going to add a lot more Go code to get this engine up and running. Okay, so when I export it out, I use the file export or the project export that we previously made in one of our videos prior to this, and I noticed that we didn't have the linker flags then. So if we go up here to build, and then I think it's project template, launch JSON, you'll see that there's no linker flags here, and we do need our linker flags, otherwise we won't be able to link our project. So we're just gonna copy this and just paste it in there, and then copy, not that one, this one, the GL one for that. So that's one of the changes we definitely need. The other one is the build tags flags. So right now we're not using OpenGL as our build flags, and of course we're probably going to use Vulkan by default. But for my current porting process to get things up and running, I need to be able to see things. So I'm going to add this tags OpenGL in here so that it builds with OpenGL. So that's it for that file. Another thing that my application does is it deals with file system stuff, and it exports images, and it's a pixel art program for drawing stuff. So it exports out images and it exports out animated GIF files. So for that, we need to be able to acquire the specialized directory given the platform, whether it's Windows or Linux or Android or whatever. We're not going to do Android right now. We're just going to set it up so that it's prepared for Android, pulling the file system for where the images are on Android, among some other things. So I did want to make a create directory wrapper so that we don't have to. Oh wow, I knew what I wanted to do. I don't know if we need 777. Might come back and check that. What did we use in the previous times we did this? I feel like I've said that before. Okay, well I think they're all 755. Oh, lost my. There it is. So we want the create directory. We want to be able to delete a directory because one of the things in pixel art is you can animate it, and you want to export out multiple frames as individual files. And I store those in a folder. So I'm going to need a way to delete those folders. Delete directory. Apparently it knew what I wanted there. I guess I did spell it directly. And the last one is our special image directory, which is going to be different on each platform. And there may be complications getting that image directory. So we're going to return an error, a possible error. So we're going to return image directory. And of course, this is going to be platform specific. So here we're going to create directory. Did I spell that right? Directory.when.go. Okay, now this is going to return a string, and error. So here we're going to say user folder error os.user home directory. If error is not nil, return the error. Otherwise, we're going to return file path join pictures, not screenshots, just pictures. Thank you. And return nil for the error. And then we'll set up a directory dot nix.go for Nix systems, as you may call them. And we need to set this to go build Windows. And here we're just going to say Linux for now. I don't have a Mac to test stuff on. So I'm just going to put Linux. I mean, I guess we could do or Darwin, but again, I don't really use Macs too much, so this may not be accurate on that platform. But we will have essentially the same kind of deal. And this is just so that we can change out basically what we want it to do once we get to those systems, but we're just going to stub it in with the same code for now. Okay, and now, of course, we have a read file, but we don't have a write file in any of our code. And if I'm going to be writing out image files, I'm going to need a way of doing that. So func write file, path, string, data, bytes. It returns an error, of course, not bytes, byte. And then f error is equal os dot open file, and we're going to do path write only, create and truncate. Okay, I like create first because that's like, I don't know, I feel like that's the order of operations. If the error is not nil, we're going to return the error. If error f.write, the data that we're passing in is not nil, I'm going to return error. And then return fclose. So here, when we go to write, that means that the file is open. I think we need to possibly close it here as well. I don't know if it closes whenever there's an error out of write. It returns the number of bytes written and an error, if any. Write returns non-nil. It doesn't tell us if it closes. I guess we can just check here. So if there's an error, yeah, so I don't think it's closing the file on error. It might, but c'est la vie. We'll see what happens. Another thing I want to do is I want to, since I'm dealing with pixels, I do have a couple of functions that I want to add in. I'm going to add in one for func color, color 8 actually, equal RHS color 8 bool, and this is just an equals check. And then we also want, I'm going to put it at the bottom, func LHS color 8 similar RHS color 8 tolerance uint 8. Now this one is going to, we're going to need an absolute value on this just to check because we're going to subtract the colors, and um, I don't want to have to care about what order each one of them are, order of magnitude or order of direction. So to do that, we're going to need to add in an absolute value int function, which we're kind of just jamming in here. We might move some of these out to a different package, but for now, we'll just do abs int, int, return a and int xor uint 8. Yeah, that's actually what I wanted to do. We're just forcing the sign bit to be what we want it to be there. Okay, so now we can say return uint 8 abs int lhs dot r and then minus int rhs dot grr, and we want it to be less than the tolerance, and then it should figure out the rest. Cool. Another thing that I need is the ability to set the width and height when we create a raw texture. So new texture from memory. We're gonna add in a width and height here. Width, height, and I guess we can put that before the filter. Feels better before the filter. And very simply width and height there. Okay, the last thing that I need is a bitmap. Not like an image bitmap, but like if I had an array of bytes, I can address them by bits. This is just a helper I have that I've written in my C engine that is just nice to compress some data and do some simple, indexing and stuff like that. So we're going to create a bitmap package with a bitmap inside of it. And we're going to have a const bits in byte 8, just so that we don't have magic 8s floating around. So we need a new function, byte, and we're going to return make byte length divided by bits in byte plus 1. Okay, and this is just because this is integer division. So if our length is, say, like 3, and then we divide that by 8, it's going to return 0. And of course, we want at least 1 byte in here. So even if we pass 0 in, we'll get that back. That might be a special case we have to deal with, but it's fine. Check bitmap byte index int bool return bitmap index divided by bits in byte. Is that what I want? I'm just going to type out what I normally do here. That way I don't have to double check it. 0x01 shift index mod bits in byte is not equal to 0. Func set bitmap. That looks similar. It looks like it picked up what I was doing here. That's great. I don't have to write all that out. Then we're going to have a func reset bitmap byte index int. And in C, you use the, what is that, a tilde, a squiggly, but you don't use that in Go. You use this caret or exponential thing. Some people call it the hat operator. I don't know why. I guess back when C++ had there was a thing they called the hat operator, which would do like shared pointers or something like that. That died real quick. I haven't seen that ever since the announcement. So we're going to need a toggle, and let's see, it should be able to figure that one out. It's pretty straightforward. And we need to be able to count our bits. So let's see, count is equal to 0. The length is equal to the length of bitmap times bits in byte. And then we're going to say for that, if, and then check, yep, and then return count. This just counts how many bits are enabled. And then we want to count inverse. Count inverse. Now, of course, I was just going to say that, of course, we can do essentially the count and then subtract the total by it. So it did what I was going to do anyways. Now we want to do a func length for byte count. And this is going to return how many bytes we need for this many bits. So it's going to be byte count divided by bits in byte plus 1, which this is going to be what we saw up here, length divided by bits in byte plus 1. So we can actually put this in. And that way we don't have to type out twice. And then, of course, a func clear bitmap byte clear bitmap. We're going to use that new clear function go. So that should be all of what we're looking for. Cool. Okay, so that's pretty much it for what I need so far. No doubt I'm going to make another video like this where I add in a lot of the other stuff that I'm going to be needing for the Pixel program that I'm porting over. But for now, we'll end it here. I am going to need to set up how we do the drawing groups though, so that'll be in another video. But I did modify that a bit and played around with a basic concept for that to get things rendering a little simpler. So we'll see that in the next one.